Okay, now we're ready to get into one of the ways to calculate the capability. Okay, and that's called the capability ratio. Okay, so capability ratio is the first one that we're going to look at. And here we have the slides explaining all the math. But before we go, no, that's not the slide. Here it is. Here's the slide explaining the math. But before we go into that, let's go back and talk about the garage again, okay, so we understand how this is done. So let's say that we want to answer the following questions. How many cars can fit into the garage? Okay, this is the question. How do you calculate that? Well, first I need to have the width of the car, right? So what is going to be the width of the car? So let's say that the car has, 6 feet. What is going to be the width of the garage? Well, let's say that the garage has 12 feet. How many cars can fit into the garage? So you know this answer. You guys are smart. We know that 2 cars can fit there. But what is the math that you calculated there? So the number of cars was equals to the width of the garage divided by the width of the car. In this case was 6 divided by 12, and the answer was 2. And that's how you calculate. That was easy, right? So what if the garage had, let's say, 6 feet? So garage, I'm making an effort, okay? My handwriting is very bad. I'm making an effort for you guys. So garage is 6 feet. The car is still 6 feet. How many cars can I fit? 6 divided by 6 equals 1, right? 1 car, okay? Here are 2 cars, okay? What if, okay, my garage was 4 feet? What's going to happen now? Well, I know that it's not going to fit, right? But if I plug into the math, the number of cars will be, so the garage now is going to be 4, cars is going to be 6, so it's going to be 0.67. So I know that I can fit 0.67 cars. So if you think about that image, right, of the garage and the car, we know the car will be bigger, right? My drawing was bad. Let's make it like this. Of the garage, right? We know that this one, the garage, was exactly the same size as the car, right? Yeah, I know, really bad. I hope you guys can do a better job. And I know that this garage can actually fit 2 cars. So that's the same logic of the equation that we're going to do. What does that mean? That means that the number that it's going to be the result of the equation, it's going to be the number of 3 times standard deviations to one side or to the other that can fit into the garage. So instead of thinking about a car, think about 3 standard deviations and 3 standard deviations to this side and to this side, okay? And that's the size of our car in our distribution. So if it fits, it's going to be 1. It's less than 1, doesn't fit. More than 1 fits with extra space, okay? So going back to our math, that's exactly the same thing as we saw before. It's called a CP. So we have the CP here. It's the capability ratio, and it's going to be the specification width divided by the actual process width. And as I explained, the process width is 3 standard deviations one side, 3 standard deviations to the other side. So what is the specification width? What is the size of the garage? Upper specification limits minus lower specification limits. What is the process width? Is 3 standard deviations to one side, 3 standard deviations to the other side, or just 6 standard deviations, okay? And then the result of this math will give me that number that we just saw on the paper. It will give me how many 6 standard deviations can fit. Okay, 3 to each side. Okay, so if it is less than 1, and here you have it here, if it's less than 1, if it's equal to 1, or if it's higher than 1, right? So less than 1, the spread is larger than the desired spread, right? The distribution is too high, the car is too big. If it's 1, is exactly in the middle. And if it is more than 1, it means that it fits more than 3 standard deviations to either side. And then when it's more than 1, you have this kind of numbers that explain a little bit more. If it's 1.33 or more, it fits 4 standard deviations. If it's 1.675 standard deviations each side, so and 2 is 6 standard deviations each side. So it means that the process is a 4 sigma quality process, or a 5 sigma quality, or a 6. So most of the problems will ask you in a 3 sigma quality, but the problem can ask you a 4 or a 5 or a 6. So you have to interpret the number. The result have to be more than 1.33, more than 1.67, sorry, or more than 1.2. Hopefully you guys didn't heard my kids screaming in the back, or maybe you did on this video.